I'll tell you what, being able to probe my banana with one hand sure is handy. Yep, 150K, that's ripe. Hey there YouTube, this is SJM4306 back with another review. This time, this is actually something really interesting, I think. So I was contacted by a company, and hopefully I'm pronouncing this right. It's a Guangzhou Bituto Electronic Technology Co. And basically, they are they provide global sales as well as after sales of Miniware products. And you may have seen I've reviewed one or two Miniware products before, a portable oscilloscope, and the video for that was actually pretty popular. So there's that, and I don't know if I did post a video of it, but I do have one of their little portable logic analyzers as well. And both of those I actually still use to this day, pretty much every day, just to check things out when it's not convenient to hook up a full-size oscilloscope. So these are products that I personally use, and they actually contacted me and they said, we're coming out with a new product now. There is a caveat to this. This isn't the final presentation of the product. This is actually kind of a pre-production like example of what the product will be. So don't expect that when you order this, when it's actually released publicly, that you'll receive it in exactly this format. But in general, in terms of like the features, the casing of the the enclosure for the actual device itself, it should be very close to what I'm demonstrating today. Now, what this basically is a smart tweezer. And you might be thinking, what the heck's a smart tweezer? Well, it's sort of like if you took a pair of tweezers and combined it with a multimeter. And the idea is, it's really annoying to probe surface mount components with like handheld multimeter with separate probes. And this is something that I deal with constantly, and it definitely is a pain. So what this does is it combines the actual probe itself into the body of the multimeter, and it's small. And so the model number on this is the DT71. I believe that it will be coming out sometime later in the year. I'm not sure on the exact date, but I'll have links down below and everything set up. So if you guys are interested in checking one of these out or picking it up, you'll be able to do so when it's available. Now, a little bit of technical information before we get into this. It has a built-in battery. It has a built-in OLED screen. If you guys have ever seen their line, Miniware's line of portable soldering irons, I believe it uses the same screen as that. And it has various smart gesture recognitions. And I guess there's an accelerometer in it, so it can actually detect whether you use it left or right-handed. So left-handies rejoice. And in addition to that, the actual mechanism itself is really interesting. We'll take a look at it. It basically, instead of using like a spring for the actual tweezer mechanism, it uses magnets. It has a built-in lithium battery, and they specify it'll run for about 10 hours continuous, which is half decent. And given the size, you'll understand that that's actually pretty impressive for how small this is. I guess we'll just start opening this up. Here you can see, designed by eDesign, Miniware Smart Tools. And yeah, there we go. Nice little placard. So this is how I received it, but as I said, you'll probably receive in different packaging. Here we have the, looks like a charging jack. It actually uses Type-C, which is nice. I like to see products that integrate Type-C because a lot of my chargers now are Type-C. And here is appears to be a 3.5mm jack. We'll have to check out what that exactly is for. And here's a 4-pole jack that goes into the body itself. So it is slightly less convenient that it doesn't have the USB jack on the device itself. So you will need to carry this and make sure you do not lose this dongle. But it's nice that they include this and that they include a relevant USB standard instead of like an ancient mini or micro. So other than that, we have the tweezers themselves in here, and let's see how this opens. So we have, first off, the body itself, which this is crazy small. I don't know what I was expecting. Oh, I see what's happening. You can plug this in and plug this part into the tweezers. That's rather interesting. Yeah, you can see the tiny OLED screen here. And the resolution on this is, let's see, 96 by 16. So it's very similar to, they sell similar OLED modules for Arduinos and such. But yeah, you could see here, uses metal. There's some protective plastic, it looks like. And very shiny aluminum, and model number is etched on the side, DT71. Very nice construction. This feels solid. And kind of hard to believe there's a battery in here. It's actually pretty light. You can see there's a standard 4-pole mini jack. That's interesting that they're using like headphone jacks and stuff and such for the actual connection, because I mean obviously these are reliable and they're a mature connection technology. And on the very end you can see there's a touch button, which is very neat. So instead of having a physical clicky button, you get a touch button there. Now what I'm interested in seeing is how the tweezer part actually feels. Because as I said, they use little neodymium magnets in the corner there. Kind of hard to see. I don't think you can see. But trust me, there are little magnets to both repel and to attract so that they spring back. And this is going to be a lot more reliable than using like spring steel, which would eventually wear out. And these tips are actually nice and pointy too. I could poke myself with them. So that'll be good for getting through oxide layers and whatnot. And I believe these are removable. Yeah, there's 2 screws. And they're actually color-coded. I really like that. Green and blue for positive and negative. So you can actually replace these, which is very good. And it looks like there's some plastic to allow, because you can see it kind of might flex a tiny bit. So that actually ensures that when you clamp down, it aligns properly. So it goes tip to tip there. Very nice design on that. Just gonna plug this in. I don't think the orientation matters at all. There we go, and it turns on instantly. And here you can see resistance, I'm assuming, diode, capacitance, inductance, frequency. It actually has a frequency measurement. That's interesting. Voltage. And then it just cycles through again. So that's actually really cool. So let's just see what else in terms of the test specifications. So resistance, it'll measure from 0.1 ohms to 2 mega ohms, and with an accuracy of 1%. Capacitance, it'll go down to 1 picofarad all the way up to 400 microfarad. So you can actually test some fairly large electrolytics with this, and that has an accuracy of 2.5%. Inductance, it'll measure down to 1 microhenry all the way up to 50 millihenry, so that's actually pretty useful. And once again, accuracy of 2.5%. Voltage, 1 millivolt up to 40 volts. So wow, this can actually measure. Oh, you can see, yeah, there's that accelerometer, so depending on how you hold it, and you can twist this as well to kind of get a, yeah, you can twist it around a little bit to get the right angle. As Dave Jones says, you got to get your tongue at the right angle while you're measuring. And let's see, the voltage measurement is 1% accuracy. That's pretty good. Frequency measurement, 10 hertz up to 20 megahertz. So we can actually probe some crystal oscillators on some microcontrollers. Diodes will measure silicon diodes, Schottky diodes, LEDs. It says from 0.1 to 3 volts. Maximum input voltage, that's important, -5 volts, so it can measure reverse voltage, but only to -5, and up to maximum of +50 volts, so you don't want to go higher than that. And yeah, that seems to be about it. It does have a built-in signal generator, it says here, and it's programmable from 10 hertz up to 1 megahertz. So yeah, that's a pretty wide range. So let's actually test this out. So okay, so let's just get zoomed in on here. It has their nice little logo up. Let's measure some resistors. I already really like the feel of this. They're springy, but they're not like hard to bend, because it's just magnets holding it essentially. It would be nice if there's maybe a grip pattern on here, but the plastic itself is matte, it's not glossy, so Unless you got really sweaty fingers, it should be fine. So I have a tiny little OLED screen here. Okay, let's just see. Switch over to capacitor. Measure this little C6 capacitor. And this appears to be an 0603. Here it's measuring it at, what is that? There we go, about 12 or 13 puff. Yeah, about 13 puff. So yeah, sorry about that, it's really hard to focus. Probably help if I put down something less distracting to the camera. Maybe put this in diode mode. There we go. See what it comes up as. Yeah, you can see 0.6 volt about diode drop. So yeah, it's measuring. It's probably a transistor. So let me grab some more stuff that'll be interesting to measure surface mount wise. Okay, so I grabbed a few things and I figured out, okay, so the mode that I was in before, you can see that M, that means it's manual. So if you press and hold, it'll go to identify and it turned into an A. So now it'll try to auto recognize what it is you're measuring. So if I get this surface mount capacitor, see this is about 8 microfarads. This is actually quite a large multi-layer ceramic capacitor. Here I have a tantalum, and the markings on this say it's 336. So we'll go and measure that. Let's get a better. So perhaps it's too large. It's measuring it as a diode, oddly enough. So for this, we know it's a capacitor, so let's go back. To go through, press and hold to go through the menu. You can actually calibrate it. Actually, I'll show you that right now. To calibrate it, it asks you to close the tips, keep it closed, and then open them. And then save data. You just click it to save. There we go, and now we're in manual mode, so let's just bump this over to capacitor. Let's just see. About 33 microfarads, so yeah, it's actually almost 34, so pretty spot on to what it's marked as. Here we have a surface mount inductor, and it says 1R5, so I'm guessing 1.5. Let's just switch this over to auto identify. There we go. Yeah, 1.4 micro. So it said it was about 1.5. So yeah, you have to really make sure you pierce in. A lot of these solder joints are kind of, especially if it's lead free, they kind of tend to be not very highly conductive. So you got to really pierce through. That's why these are pretty sharp. Let's see a diode, in this case a LED. Just grab one that's large enough. You can kind of see how it pulses while it's reading. That's interesting. Yeah, the forward voltage is 1.83 volts, which for a red LED, that's correct. Here I have a 22 ohm resistor. I'm just gonna grab one. This is an 0805. And here it says 21.6 ohms. So it's supposed to be 22. So fairly close. Here we have a whole bunch of 0.1 microfarad capacitors. Let me grab an 0402, which is actually, is that an 0402? Nah, that's an 0603. Here's an 0402. It's like a speck of dust. Okay, let's see how. Let's do the 0603 first off. This is on auto still. And it's measuring as about 90 nano, which, yeah, that would be about 0.8 or 0.08 micro. So before I accidentally breathe on it and it blows away, let's put it away. Here's the 0402. Geez, this is small. Yeah, about 68 nano there, 66. Yeah, I would not be able to probe this with regular multimeter probes. It would just like instantly either be crushed or fly away. So yeah, I'm liking these already. Next up, we have 1K resistors. And let's just grab directly from here. Here we go, spot on. This does auto range, so that's actually rather nice. And yeah, just about exactly 1K. Very nice. And here I have a bunch of other SMD resistors that I've pre-sorted. So these are 10K. Just grab one out of here. There we go. It says 9.94K. Let's see. Let's do something low valued. I have some, what are these, 10 ohms? Yeah, they're 10 ohm resistors. Let's see if we can measure them. Yeah, spot on. 10.0 ohms. Very nice. So yeah, I like this auto mode the most. I don't have to mess around with... sometimes it does accidentally detect. I'm guessing depending on if you're not getting a good grip on the item, it'll incorrectly detect like a capacitor as a diode or something like that. So you might have to push into the manual mode, but I'll mostly be leaving this in the auto mode. And we'll go. This is how you access the signal gen mode. And here we're outputting a 1 kilohertz sine wave. Noise 0.1 megahertz. User. So they're different presets. And you can change the user one. You can do a single pulse at 10 kilohertz. And then back to a sine wave. That's really cool. If we go back, next up is calibration, which I've already shown. Really like this screen. It's like really clear, very high contrast. It's very small, you can see next to my thumb, but it is very clear, very readable. So I'm really liking that bit. And there's like a nice nice glass. You can see there as I'm tilting it's doing different stuff. You can see there's like, I don't know if this is plastic or glass covering it to protect the screen, but that's very nice. I like that. And we'll press and hold again. It takes us back into manual. So let me grab a coin cell and we'll try to measure voltage now. Here's the newest project I'm working on, and I have a coin cell from it that I can extricate. There we go. I'm going to borrow you for a sec. Oops. And here we go. So let's see. It says it can do -5 volts measurement. And it warns you it's negative, which indeed it is, and it won't measure it, unfortunately. So you got to get these the right way around. And here, yeah, 2.98 volts. Let's just see if we, yeah, if I just close the tips, it's measuring about 2 millivolts, so there's a little bit of noise. Let's see if I really squish them down. Yeah, 1.8, 1.7. So yeah, all in all, that should be really useful. I do a lot of stuff with surface mount components, so that'll definitely come in handy. So yeah, I do a lot of measurements with surface mount components. I assemble my own boards, and most of the projects I make are predominantly with surface mount components whenever possible. So this should actually be very useful for me. And I do salvage certain parts that aren't quite so easy to get, like large value capacitors and inductors, like ceramic caps and whatnot, from circuit boards. So it's very good. Not all of them are very visible to marking. Some of them are unmarked. So you kind of have to measure them. So this will actually be very useful in that as well. I really do like the magnetic arms. These will pretty much last forever. So I'm glad they went the extra expense instead of just putting a cheap leaf spring in there, like a steel spring. These are a lot smoother in operation, and it's very easy. So you're not applying a large amount of force when you go to probe the item, so you're not as likely to ping it off. And it does give enough resistance when you release it. Just springs open. Feels very good in the hands, kind of just like a regular pair of tweezers. And they're about almost exactly the same size as the pair that I use for soldering. Clearly I won't use this for soldering. This is just for measurement. But I do like the actual tweezer ends are very, very sharp, and they are what appears to be gold plated. So they should be resistant towards corrosion on there, and it's good just in case they do get corroded. You can actually replace them. The left and right hand like motion sensing, I'm guessing there's an accelerometer in here, is a nice touch as well. I'm mostly right-handed, but depending on what I'm doing, maybe I will have to use my left hand for certain measurements, depending on where it is on the board and if I can move myself around it. But yeah, it's very nice that it has that ability. Yeah, so all in all, I'm actually very impressed with this. The only kind of added things I wish you could add is if there were a way to change the setting for using the accelerometer to flip the display, if you could say like manually set it and then leave it at that, because sometimes if I'm measuring something, maybe I'm hunched over and my hand might accidentally go a little bit twisting further away. I don't want the display to flip. So if I can permanently set it to right hand mode, that would be really nice. The single touch button is sufficient for most of what you want to do, switching through the menus. And the unit itself will just kind of time out and go to sleep if you don't measure anything or if you don't touch anything after a little while. Very nicely designed though. I'm used to seeing they put a lot of polish into the actual hardware aspect as well as the software of all their products. So it does not surprise me that this feels very sturdy. This will last a very long time. You can see the jacks themselves that are used for the actual connections. So yeah, I should expect this to last a very long time. And they do sell other shape tips, like ones that bend downwards and other shapes as well, which will be very useful. So once this releases, I'll probably pick up a couple other probes and see how they work. As for charging, so here's a charging cable plugged in. Figured out what that little LED is. It's a charge indicator. And you can see here, it actually says I guess that's a firmware version and the DFU, so you can actually upgrade this over USB if they come out with new firmwares. How neat is that? Sort of stinks. It would have been really cool if there was... They couldn't fit a Type-C connector on here, but you might have been able to fit a micro cable, but that would be a very tight fit, and it would kind of hinder pressing the button while it's charging. But that would have been neat to see, but definitely I can kind of understand why they had to go with the dongle itself for charging. But like I said, maybe the next iteration, even if it were a tad bit longer and had a jack on its body integrated into there, I would have been really happy to see that. So yeah, super huge thanks to Guangzhou Bituto Electronic Technology Co. Limited for sending these in for me to check out, and also super huge thanks to Miniware for designing and selling these products. I really like to see every new product that they release. I like to see what goes into the design of it, and they've been doing a really good job recently with their portable kind of lab, like a portable lab device tool set that you can carry in, a small briefcase or your backpack. So yeah, these are something I will definitely use in many future videos for debugging stuff, as well as for testing components and stuff like that. And yeah, if you guys are interested, I will have links down below to the sales page once that's up and live. And if you are interested in these, please feel free to, ask down below. And keep in mind, this is a pre-production unit, so it's missing, you know, an instruction manual and maybe a couple other accessories or things that may come in the final unit. So just keep that in mind. But in terms of like the representation of the actual hardware itself and the firmware, this will give you a pretty good idea. But hopefully maybe some of my suggestions I'll at least take into mind, and maybe in future revisions of this, if there's a DT72 or some features or menu settings that I suggested. Anyway, yeah, it's actually a really cool product, and I love these little OLED screens. So they're awesome. Anyway, I've rambled on for long enough, and I will see you in the next one. Bye.